Okay, today we're going to go over a little bit of an algebra review, and it's going to be about literal equations, and let's see what we mean by that. What we mean by this is that we want you to be able to recall or learn how to manipulate equations to solve for a specific variable. So let's take a look at what that looks like. So here we've got a couple different equations. In the first one here, we want to solve for the variable p. So area equals 1/2 a times p. That is the book's equation for area of a polygon, right? And area of a regular polygon. So a equals 1/2 a times p. So we want to solve for p here. We want to get p by itself, which means we have to divide by little a, right? And then we have big A over little a equals 1/2 times p. Now p still isn't by itself. But if I multiply both sides by 2, which is the reciprocal of 1/2, then 1/2 times 2 is just 1, and I have p by myself. So p should equal 2 times my area divided by the length of my apothem. So that's how we do that. So what do we use this for? Well, if I was just solving for the perimeter and I didn't want to manipulate all those numbers, if I manipulate the formula and then put my numbers in, I can just solve for p without having to write as much. Okay? So it's really a time-saving measure, especially when you are looking to deal with lots of big equations. I know when I was in engineering school, I would do this a lot. I would manipulate the equations before I put my numbers that I knew in. And I would do that also because I could cancel my units out and make sure that I had done the math right as well. So here we want to solve for B1. So this is the area of a trapezoid. We want to solve for our length of one of our bases. So this is going to be a similar calculation, only because the base is inside these parentheses, I'm going to move h and 1/2 first. So let's see what that looks like. Erase some of these little circles so you don't get confused. So I'm going to divide by h on both sides, and that's going to cancel out these h's. So I have area over height equals 1/2 times b1 plus b2, right? Now if I multiply everything by 2, like I did on that first problem, I will cancel out my 1/2. So I have 2a divided by h, not b, equals b1 plus b2. Now it's really easy to solve for b1 because I can just subtract b2 from both sides. So I get 2a divided by h minus b2 is equal to the length of b1. So now the nice thing about when you are manipulating these equations is you don't really lose any of the letters. They just show up in different spots. Okay? So it's just kind of rearranging them to solve for a different variable, and you're using, you know, your same algebraic properties that you would use to solve any equation with. It's just here you're using it with letters instead of numbers. So sometimes we need to solve for a different variable in the context of a problem. So the shape of a field is rectangular in nature. Its new owner was told that it was a 20-acre lot. Now, acre is an area measurement. So I'm looking at area equals base times height, right, for the area of a rectangle. Given that an acre is 43,560 feet squared, and the front of the lot was measured at 200 feet across, so if the front of the lot is 200 feet, and the area equals 20 acres, then how deep is the lot? So I need to know that height or base. But first we need to do a little bit of calculations here. So we need to convert acres into feet squared. So 20 acres, 20, not 2. What did I just do here? Okay, so we'll just scratch that out instead. So 20 acres equals how many feet squared? Okay. Well, given that 1 acre is 43,560 feet squared, 20 acres will be 20 times that. So 20 times 43,560, and that's 871,200 feet squared is 20 acres. Okay? So I need to solve for one of my variables. I'm going to call this height and this base. So height will equal area divided by base. Okay? Now given that I've got all these numbers here that I've got to write in, I don't want to have to divide all those numbers except for once. Okay? So I'm going to rewrite this. Height equals area divided by base. So that's 871,200 feet squared divided by 200 feet gives me 4,356 feet deep is that lot. So this is a really skinny lot given that 5,280 is a mile. It's over 8/10 of a mile. It's pretty deep lot there. Pretty skinny deep lot. So I'm guessing this is probably some frontage property or something like that. But anyways, you kind of get an idea of why we would want to manipulate an equation before we stick the variables in, especially when we have bigger, crazy numbers. Okay? So what we've learned how to solve formulas for different variables, and with every different formula there's going to be a slightly different technique. You'll get used to solving most of the common ones, but this is something that pops up all the time. You will use it in science, you'll use it when you're, if you ever take any engineering classes, over and over you'll use these techniques here. So that's why we're really trying to get you to be good at them. That's it for today.